Going on, guys? In this video we are going to see an example on Cauchy Euler initial value problem. First of all, to figure out whether an equation is Cauchy Euler or not, we look at the degree of the coefficients and also the order. Here you can see degree of the coefficient is square, so x square, and the order is 2, and x power 1 order is 1, and x power 0 y power 1, right? Actually y, because we don't have any order, so y. So from this one we can see that this is the Cauchy Euler equation. Now after we found out this is a Cauchy Euler equation, what we do is we try to get one of these pattern. So first of all we have to know what kind of roots we are getting. If we get two distinct real roots, this is going to be the general solution, and like this. So it goes like this. Now let's see. To find that one, what we do is we arrange this one in auxiliary equation like this. In order to do that, we had to know the ABC values. ABC value is basically the coefficient of this one. Here in front of this one, 1 and also 1. So A is going to be 1, B is going to be 1, and C also 1. So we have A, B, C 1. Let's plug it in this equation. 1 times m minus 1, that's going to be just m times m minus 1, and plus m plus 1 is equal to 0. Now let's simplify this one. This is going to be m square minus m plus 1 is equal to 0, and here we are getting m square plus 1 is equal to 0. Therefore m square is equal to negative 1, and m is going to be plus or minus square root of negative 1. That's going to be plus or minus I. Here we are getting a complex number. So since we are having a complex number, this means we have to go for this one. We are getting a complex roots. So this is going to be our general solution for this differential equation. Uh, but in order to plug this one into this equation, we have to know what is alpha and beta. Alpha is the real number and beta is the imaginary number. Here we have 0 in front. So 0 plus or minus I. Beta is, this is alpha. Alpha is 0. And this is beta. Beta is I. Okay. Now beta is I. Actually, the coefficient in front of I is 1. That's the beta. The coefficient in front of I is a beta, and alpha is this value. So alpha is equal to 0, beta is equal to 1, and now we have alpha and beta. Now we can go ahead and plug it in this equation. X power alpha, that's going to be x power 0. So y of x is going to be x power 0, that's going to be just 1, and then c1 cos beta is going to be just 1, and ln of x, so ln of x, just we keep it as x, and plus c2 sine beta is going to be 1, so we keep it as 1, and then ln of x. So this is going to be the general solution. Okay, now they have given the initial values. We have to find out the particular solution. That's the purpose of this initial value. Now let's go ahead and plug this one and see what we get, because we have to find out, to give the particular solution, we have to find out this c1 and c2, and then we have to plug this back in this equation. Now let's plug this one and see what we get. Now let's get rid of this part. Okay, and here I'm going to continue this one right here. So first let's plug 1. Y1 is going to be c1 cos ln of 1 is going to be 0, and then plus c2 sine, again ln of 1 is going to be 0. So we get like this, and we know that cos 0 is 1, so that's going to be just c1, and sine 0 is going to be 0, so that the other term we don't have to worry about that. And we know that y of 1 is equal to 1, so we can equate this into 1, and that's going to be our c1. And now we have to find the derivative of this one. Let's find the derivative. Derivative of cos theta is going to be negative sine x. So here we are going to have c1 negative sine ln of x and this is going to be a chain rule. Inside derivative is going to be 1 over x. Okay, so this one multiplied by 1 over x, and let's go to the next term. C2, derivative of sine is cos, so cos ln of x, and the inside derivative again, that's going to be 1 over x. Now this is our first derivative. Now we know that y prime of 1 is equal to 2, so y prime of 1, let's see what we get from this one. So here we know c1, let's put the negative in front, sine ln of 1 is going to be 0, and then multiply by 1 over x, and here we have c2 cos ln of 1 is again it's going to be 0 times 1 over x, and from this one we know that, okay, 1 over x, x is 1, so we can plug that 1 over 1 here too. 1 over 1, so it's not going to change anything. So here we know that sine 0 is 0, so this whole term will be 0, so we can get rid of this, and this is going to be c2 times 1, and 1 over 1, that's also 1, so c2 is going to be equal to y prime of 1, and y prime of 1 is given, that's 2, so 2 is equal to c2. This is our c2 value. Now we have found out c1 and c2, so we can write our particular solution. So yp is going to be equal to c1, that is 1, so we can just leave it. So this is going to be cos ln of x plus c2 is 2, so 2 sine ln of x, and that's going to be the particular solution for this differential equation. I hope this helps. Thanks for watching.